Today in 2.4, we're talking about normal curves again. I'm going to kind of explain it by going through the activity a little bit. On the activity, it was just made-up test scores of these guys. And to be a normal curve, the first thing you have to do is be symmetric. How do you guys feel that this data right here is very, very symmetric? It's not perfect, you know, but it is symmetric. And then there's this also thing called the 68, 95, 97.5 rule, which we usually call the empirical rule. 68% of your data, and it'd be rough. It doesn't have to be perfect today, but roughly 68% of your data would fall within one standard deviation of the mean. So that's what happened on our activity, that within one standard deviation, there was 17 dots in there out of 25, and it came out to be perfect of 68. Doesn't have to be perfect. Then in two standard deviations, there was like 23 dots out of 25. What's interesting is a lot of people like, do you count up the original 17 that were in the middle? And the answer is yes. So if you made that mistake, that's very normal. But that was like 92%, which is pretty 5%. So we're going to have some parameters on that. So let's go through today's worksheet and realize these percents, you definitely want to take it. It will help you answer all the homework questions today. But we're kicking it as a quick review. We did in 2.3. Some tests about these Iowa Basic Skills kids where they had a mean of 6.84. They use that weird symbol for mean sometimes also. And a standard deviation of 1.55. Because it's been a long weekend, I want to refresh your memory. Do you remember you could find those numbers very easily by using the applets and clicking on the normal distributions applet right there, and then in your mean and your standard deviation. They tell you, it'll give you all those numbers on your normal curve right away, so you don't have to do much math behind that. But it says, what percent of these scores have vocab scores less than 3.74? So you notice that is one of our tick marks on there, right? So we probably need a calculator to do this stuff today, but we definitely don't have to do much math. Less than 3.74, same bar right there that I highlighted on my little like normal curve graph, and less than that would be in all of that stuff. So that is where I made you put these numbers down there on the bottom last time. There's 0.15% of data in that little wedge right there, and 2.35% in this wedge right here, and when you add those together, you will get this 2.5%. So on the chart, you just have to know you were on this tick mark and you wanted to go below it. Using our guide over here, it says, okay, 2.5% of the data is below that dude. When it's proportion of 7th graders have vocab scores between 9 and 9.9. So check this out. What if I went between these two pink ones right here? How do you feel that is like standard deviation from the mean, which is 34 plus 34, which is 68% of the data would probably fall in there. And then you see in that spot right there based off of this dude. So we just add those together. If we add 68 plus 13.5, that means that 81.5% of the data would fall between those on a normal situation, which a lot of graphs and data in the real world is normal, but man, some of it is not normal. So our job today is to basically how to use this chart with all the percentages to find which little bars were in between and just add those dogs up. So note this rule that we're using today is called the empirical rule. It only works on normal distributions. If it's not normal, we can't do it. So here you go. What do you think about this guy? Would this be normal? First, you look at the shape. It's got to be symmetric. Do you feel that guy is symmetric? Nope. So that is not normal because the data is not symmetric. That's the easy first test. Is there no way this would fit? Not a symmetric, right? Other things happen when it's skewed, right? So, and eventually we'll get to studying some of our own data and start making some like predictions with that, which will be a little more enjoyable at the end of the year. So, cool. When we get here, sorry, on your chart, This dude right here is supposed to say 68, and on your paper it says 658. Sorry, there was a typo and I didn't catch it in time. So if you want to scratch your number out on your paper and put a 68, this is kind of the job of the rest of the day is, can we determine if this is normal or not? So here is 67.4. And if you are truly normal, of course you have or bell-shaped, but then your data has to fit those percentages roughly. It's not always going to be exactly percent within one standard deviation. So we're going to make a class rule that we're going to have like a tolerance of 6%. So if I do 6% lower than 68, I get 62%. And if I go 6% higher, I get 74. So if our data is bell-shaped, like symmetric, we have somewhere between 62 and 74%, that's going to be up. It's like, hey, that's deviations. But let's just dive in and try it. So we'll make up that I had a sit-up contest going on, and 62 total people competed. It says 33% of these students fall within one standard deviation of the mean. It says percent of those students that fell within one standard deviation. Let's do it. 2 total. All right. Well, let's punch that into the calculator. See what we get. 33 divided by 60. People that are within one standard deviation of the mean. And if we round that to the nearest percent, remember we got to move 2 decimal places to the right, what would you get? 53%. So we're going to asking, is that enough? This is also a typo. That should say 68 instead of 65. I'm sorry I had all these typos that I didn't catch in time. But according to this empirical rule, which is also called the 68, 95, 97.5, is this enough? Here's the rule. Be within one standard deviation. This guy right here has to be in that range. Does 53 fit inside of there? Nope. So that means that answer is going to be no. So I can rule 2 right away because their answers were yes. And it says, no, the percent is 95%, too far away. All of these 5s today, I am so sorry, there's a typo. They're all supposed to say 68%. And it's way on your homework because I literally snipped these out of homework. So it should all say 68 instead of 65. My fault. Sorry about that. Too far away. We're given 6% of tolerance, either above it or below it, and 53 is way too low, right? It's not going to be normal in that situation. Cool. Another one. Holy data sets, right? It says to the right there is students. Love that number. That's a round number to deal with, 100 total students. They just gathered all the scores on the Algebra 2 test. They want to know, is it normal? Here's test 1. Would you call that symmetric or not? What's your guess on the graph, the way it looks like? Symmetric or not? I'm going to say yes to that question. So that means he's eligible to be like normal. But then what we'll do is you'll get these summary statistics, and holy cow, are they weird decimal numbers. Do you see like the average 3.5 deviation 8.04? We're going to make it easy on our brains. And we're going to round these to like 7 and 8. Because I guess them. So it says we're going to use 73 and 8. 73 is the mean, and so I'm going to put the number 73 in the middle because he's our mean. And then you could always go use your applet if you wanted to, but how do you feel that these numbers are like 8 away? Like 8 above is 81, 8 above that is 89, and 8 above that is 97. So you could always punch those into your applet and then go below. Why don't you write those guys down here, though, so you could look back and see how you did this. There's about 3. They'll be on. See, is it normal, and would you believe that I need to see deviation? between 65 and 81. Are you with me on that? Like, that's what I want to look at. Holy cow, are there a bunch of them, right? There's 100 up there. So here's what I did. I went low boy. You see there's a 65. That's the lowest number that I got. The cool thing is they're all in numerical order for us. And the highest one is 81. So in between there is going to count, right? So I know I highlighted that real quick. If you want to highlight, I have some in the drawer over there as well. But I got to sit there and count them all up. Worst part of today's homework is to count them all up. Awesome. I made it 10 by 10 to the size of this grid. So I'll let you count them all up and see how you got. Like, do you see how I just counted the solid rows first of all the 10s, right? So I have all the way up to 60 on that bad boy, right? And then I got 4. So 60 plus. How much did you get on all of that? You said 74. Different. You guys different than 74. 60 plus 4 plus 7. I got to double check. Cool. Do it. I'm counting up how many 65 and 81 in this data set. Does that sound okay? So each one of these, there's 1, 2, 3, 4, 5, 10 wide. So every row counts for 10. So I did 10, 20, 30, 40, 50, 60. Then there's 4 more right there and 7 more right there. Are you with me on that? So does that kind of make sense? So 71 of them fell within 1 standard deviation of the mean. I know, that's a lot to count. They want to know what percent of the data is that. Here's why I like that it's out of 100. If you take 71 and divide it by 100, guess what percent you get? It's 71%. That's what percent is all about. So 71%. Here's your first test of the day. Does that work to be normal within 1 standard deviation of the mean? There's our parameters. Are we okay in that zone right there? Anywhere between 62 and 74 is considered decent. Are we? Yes. So we're going to keep going. Right? So, okay, that works. Now within 2 standard deviations of the mean, you see how I wrote this list out? That'd be between these bad boys, between 57 and 89. Awesome thing is I got 71 of those dudes accounted for already. I just got to go find some more. So I used the second color highlighter, and I highlighted all of those between 57 and 89, right? And instead of counting all those that way, I'm going to do the reverse effect and just count how many are not there, because there's totally 100 here. So there's 1, let's see, 1 that are not in there, and there's 100 total. So how many should be in there if 6 are not in there? 94 of those bad boys, which means that would be 94% because that's out of 100, right? And with 2 standard deviations of the mean, right, you're supposed to be 6 away from 95. Or my boundaries right here is 89 to 100. Does 94 fit in that data set? Sure does. So we passed phase 2. Then we got to check to see if, like, how many dots are within 3 standard deviations of the mean. So that is like between 49 and 97, and that's like all of them, but that 98 was the only one that didn't make it between 49 and 97. So how do you feel that in that situation, which is obviously 99%? To be within 3 standard deviations of the mean for this rule, you have to be very close to 97.5%. So between these 2 boundaries, because I didn't even go over 100% because it's impossible to go over 100%, but does 99% fit between those 2 numbers right there? Yes. So can we consider this data to be quote-unquote normal? The answer is yes, because the empirical rule works. That's what this is the fancy name called. It's also called the 68-95-97.5 rule, which we're going to get so comfortable with. Like, I appreciate you buying into this today, but we've done it 2 days in a row. It's an important thing that's not going away. So please ask questions if you have them today. All right, cool. So All good. Let's try another one. Last one of the day here, baby. I think it's the last one. It says, even though this is bell-shaped, would you agree this is fairly symmetric? Yes or no? Right? Totally fairly symmetric. So that answer, it says, is that. It says, let's see if it's normal. Nasty number, nasty standard deviation number. We're going to round them to whole numbers so we can deal with them. Sorry that it's small, but we'll call that 107, and we'll call this 19. And it says, count the dots that are within one standard deviation of the mean. This is not a pretty graph, so I'm going to help you out. If you want to put a box around them, you see the mark right here where it's got 100. It's going to include all of those that are at 100, but not the ones next to them, not the ones to the left of them, because those are at like 90. And then it's going to go to the dots that are between 120. So like put a box around those, and I'll do you a favor and tell you there are 61 dots in there. I counted them all up. That's what this says. It doesn't look, it looks like lol, but it's 61 dots. Sorry. Sure is. 126. So I'll explain where those numbers came from in a second. Here's the first thing. Are you cool that like this is within one standard deviation of the mean? The mean, we're calling it 107, so I wrote 107 down. One standard deviation is 126, and 107 minus 19 is 88. You could also do that in your applet. Sorry, I thought I opened the applet. You could also do that in your applet if you put the mean of 107 in and the standard deviation of 19 and hit plot. It's going to give you that 107 is in the middle, 126 is to the right of it as one away, and 88 is below that. So the reason why I put the box around that is because people ask great questions like, how do you know where 88 is? It's like, where are these big rows of dots? So the textbook told me those are not at 88. They're at like 85, you know, so they're below that. But here's the moral of my story. 61 dots there. 61 dots are within one standard deviation of the mean. And do you see up here? 77. So let's see how many are in there. 77 divided by 77. What percent are within one standard deviation of the mean? By 77. And you said how much? My calculator is being silly. I agree with your number that it was whatever you said, 79%. Is that right? 79%. So 79% of the dots are within standard deviation of the mean. Was 79%. That work? That too many dots in the middle. Is 79% okay or not okay? It's not okay. It's too much. There's too many dots in the middle, right? It's not normal in that situation. You can kind of see it now from the shape. Aren't they all squeezed in between here, and there's very few dots? It's like almost 80% of the data is in between there, and it's only supposed to be about 68% of the data. So it is, even though it's bell-shaped, it is not normal because there's just too much. You could also have a bell-shaped 30% of the data within there because it's too spread out in that situation. So to be normal, you got to be bell-shaped, and the percents that we went over today have to fit close within that 6%. Cool. Let's try some homework and see how we do. Let the charts tell you like all the percentages, and I'm happy to help you.